Hi there, and welcome to this lesson. Now, in this lesson, we're doing coordinate geometry, okay? And under coordinate geometry, we'll be learning about the equation of a line. Okay, at this point, I remind you to set the video to play in 1080p HD. Okay, you can do so via the settings icon on the bottom right. And if you have any issues at all as the lesson progresses, please feel free to get in touch. Okay, you can do so via the course dashboard. Okay, let's jump right into the lesson. Okay, the equation of a line. Now, the equation of a line. Consider this figure. Okay, I have my Cartesian plane, I have my two axes, x and y axis, and I have this line. Okay, and basically, what is the equation of a line? Now, the equation of a line is something that is an equation that defines a line. Okay, and so far we've learned about the gradient actually forms part of the equation of a line, because the equation of a line tells you absolutely everything you need to know about that line. Okay, and the equation of a line is a function that relates the x values and y values of every single point on that line, every single possible point on that line. Okay, now it's pretty much a formula, if you'd like to call it that, and a function where you have y is as a function of x. Okay, and anytime you impute the x values of any point on that line, okay, any points in that line, you would get the corresponding y values. Okay, so now, like I said, the first thing, when you're trying to define a line, the first thing you talk about is the steepness of that line, i.e. the gradient. Okay, and in this case we will consider the gradient of this line, and like I said, the gradient of the line is related to the angle that the line makes with the horizontal x-axis. Now, the next thing I'm going to do here is I'm going to mark this point C, where the line cuts the y-axis. Okay, and this point is called the intercept. Now, I want you to think about the line, and to be honest, I'll tell you the truth, at this point, to define this line, this is all you need. You need the angle that the line makes with the horizontal x-axis, and then you need a starting point. Okay, just think of this line as though it started from the point C, okay, on the y-axis, and then you know the angle the line will make. Just if you were drawing a line with the protractor, you have a starting point and you have an angle that the lines would follow. Basically, you have a steepness, and you pretty much have enough information to define that line. You can draw the line out. Okay, so you have a starting point, and then you have an angle that the line makes with the horizontal, and basically you can go ahead and draw that line. The line is defined, but usually we like to talk about our lines in terms of x's and y's. But let's go on. All right, so I've marked this point C. Okay, so we've given the line a starting point. What I'm going to do is I'm going to mark a point on the line, okay, because I want to develop a function that will work for every point in that line. I'm going to call this point A, and point A is going to have values x and y. Okay, now the next thing I want to do is I want to draw this triangle, okay, from C. Okay, and it's a right angle triangle. And what you notice is that the opposite of this right angle triangle is y minus c. Okay, and the adjacent is x. All right, and now if you were going to find, basically I have the same angle here. If you're going to work the gradient of this line here, basically from what we discussed in the last lesson, you would have that tan theta, which is also m, equals y minus c, the opposite, divided by the adjacent x. Okay, and then when I cross multiply, what I have is very simple. I have that y minus c equals mx. I'll bring c over to the other side, and what I have is y equals mx plus c, and that is the general form of the equation of a line. All right, y equals mx plus c, and what this simply implies is that if you have the gradient of a line, okay, and you have a starting point, just think of it as a starting point. It's called the intercept, the point where the line cuts the vertical axis, the y-axis. You basically have a function that will relate every single point on that line using what you have here, y equals mx plus c. Okay, so let's say I have a line, all right, and I'm given the gradient m and I'm given the intercept c. If I'm told that the x value of that line is 2, using this formula I can find, if I told you that the x value of a point on that line is 2, using this formula I can find the corresponding y value. You can use this formula for that line. You can use this formula to find every point on that line, because this formula applies to every point on that line. Once you're given the gradient of the line and you're given the intercept, the point where the line cuts the vertical axis, you can pretty much find the y values for every corresponding x values on that line. And that's pretty much what the equation of a line is about. It's just an equation that gives you the relationship between the x values and the y values of every single point that occurs on that line. So let's go about solving for the equation of a line. And the equation of a line can come, so the question is an equation of a line could come in different forms, okay, but then sometimes you could be given the gradient, so you have m equals 2, okay, and c, you're given the intercept c equals 5. You basically have that the equation of that line is y equals 2x plus 5, okay, and sometimes given m equals minus 3 and c equals 2, you pretty much have that the equation of this line is y equals mx plus c, i.e. minus 3x plus c 2. All right, now let's do another one. Sometimes you could be given m as 3 over 2 and c as minus 1 over 2, and it asks to find the equation of this line. You have that y equals 3 over 2x minus 1 over 2, and that is your equation of the line. Or you can multiply all through by 2 and you'd have that 2y equals 3x minus 1. So basically 2y equals 3x minus 1 pretty much just tells you that this is the relationship for this line. This is the relationship between the x values and the y values of all the points that occur on this line. Okay, so now let's go ahead and solve some examples. Now example 1, and example 1 says find the equation of the line with gradient 2 and passing through the point z, which is 3 comma minus 2. Okay, so at this we've been given the gradient of the line. So we're given the gradient of the line and we're given a point on the line, and we've been asked to find the equation of this line. Now to find the equation of this line, you need two things. You need the gradient and you need the intercept. Now the gradient is already given, the gradient is 2, but then the intercept is missing. We weren't given the intercept, so we need to find the intercept to define this line. So the first thing we do here is we have that y equals mx plus c. This is the general form of the equation of a line, and basically we've been told that the gradient m is 2, so we can write that y equals 2x plus c. Okay, so now we need to find c. And how do we go about finding c? Now remember what I told you, this equation applies for every point on the line, including the point z. Okay, so basically if you have the y equals 2x plus c, this law must apply to the point z, i.e. minus 2, which is your y value there, should equal 2 times x, 3, which is your x value there, plus c. Okay, and then when you solve this out, just basic algebra, you'd have linear equations, you'd have that c is minus 8. Okay, and that is how you arrive at your equation of your line. as y equals mx plus c. Your m is 2 and your c is minus 8. So you have that y equals 2x minus 8. Okay, let's go ahead and do solving these questions are actually really easy. There really isn't much to them. You just need two things to define a line. You need your gradient and you need your intercept. And once you have your gradient and your intercept, you have m and you have c, you have your line. And it's all about manipulating what the information that you have and arriving at your gradient and intercept. So let's solve another one. I think this one is a bit more challenging. Okay, it's a bit more difficult than this one. It's fairly easy. So example 2. Example 2 says find the equation of the line joining the points m minus 3 comma minus 2 and n minus 7 comma 2. Okay, this time we've been given 2 points. Okay, remember so far we've found the equation of the line when we're given the gradient and the intercept. We found the equation of the line when we're given the gradient and a point on the line. Okay, and now we're going to find the equation of the line when we're given 2 points on the line. Okay, so given 2 points on the line, it's pretty much the same thing. You just have to find the gradient and the intercept. Okay, so first thing we want to do, what do you think the first? Of course, we want to find the gradient. All right, and we know that the gradient m is y2 minus y1 over x2 minus x1. All right, and then when we substitute the values into that, we have that m equals minus 7 minus 3 divided by 2 minus 2, and then what we have is m equals minus 4 over 4 and m equals minus 1. So we have our gradient. Now how do we find our intercept? So we know that y equals mx plus c, and in this case we have that m is minus 1, so we can say that y equals minus x plus c. Okay, and then from this point we pretty much just put in, we pick any point. Okay, because if you worked it, you see that m would work and n would work as well. So we pick any point. Okay, and in this case we're going to be working with m, and basically this function should satisfy m. All right, and basically what we have is we have that y equals minus x plus c, so minus 2 must equal minus 3 plus c. Okay, the y value must equal negative the x value plus c. Okay, and basically when we put in minus 2 equals minus 3 plus c, and we work that out, what we end up with is we have that c equals minus 5. Okay, and something very interesting, if you actually did this with the endpoint, okay, can we actually attempt that? Okay, let's just think about it. If you did that with the endpoint, what you'd have is you'd have that 2 equals minus 7 plus c. Okay, that would be 2 equals 7 plus c. All right, and then you'd have that c equals 2 minus 7, which would give you c as minus 5. So you can pretty much use either of the points for this step, and basically you have your m, you have your c. I believe we can go ahead and say that the equation of our line is y equals minus x minus 5. And if you put this, I think let's try and work it for one of the points. Okay, let's say we're given the x value for the point n, and we're told to find the y value. Okay, we'll put our information minus 7 for x there, and once you work that out, minus 7 minus 7 minus 5, you would end up with 2 as your y value. And that is the idea behind the equation. If you did that for the point m, you would arrive at the same result, and that is the idea behind the equation of a line. It's simply an equation that relates the x and y values for every single point that occurs on that line, and it's defined by the gradient and intercept of that line. And once you have the gradient and the intercept of the line, you can pretty much just write out your equation of your line as y equals mx plus c, and that is it. Fairly simple, fairly straightforward. Okay, and that will be the end of this lesson, and yeah, bye for now.